We just announced the S32K5 microcontroller family. This is sort of a follow-on announcement to what we did last year when we announced the CoreRide platform as NXP. This is an announcement that we are making in the context of software-defined vehicles, and specifically we are addressing the zonal applications in software-defined vehicles. Zonal applications are this kind of middle layer that you find in the electric architectures of the cars. You have the central compute at the top, you have the actuators and sensors actuating the loads, sensing the different things around the car. And these zonal controllers are kind of the middleman between these layers. And the intention by the car makers to save cost and reduce development time and simplify the architecture is to combine a lot of features and integrate as much as possible in a couple of those. So maybe 2, 3, up to maybe 5, 6, 7 zones around the car. So these car makers and tier ones building these zonal controllers have a lot of challenges to integrate things into one box. One of them is the diversity of workloads they have to deal with. Different software, different algorithms coming from different suppliers. Another one is the mixed criticality from a safety point of view. So you have tasks that are not safety critical. You have other tasks or applications that have a very high degree of safety criticality. So if you think about it from the point of view of the ISO 26262 standard, we're talking about a range of quality managed up to ASIL-D, like Delta, ratings. And so mixing those together is a challenge in itself in terms of keeping them isolated, right? And then you have challenges around networking. A lot of data is flowing through the zones. And what you want is you want to keep the real time of the whole system under control. So you want to ensure the latencies in communication between the sensors, the actuators is maintained. So networking is a big piece of what we're trying to address with this S32K5 product family. And it also expands into the programmability, the upgradability of the car in the way that the car is being reprogrammed, updated over time. So this networking is a critical piece of the over-the-air updates management for the software to be deployed in a reliable and efficient fashion around the vehicle. So to kind of wrap it up, it's one piece is compute, and it's mixing applications together, and another piece is really about networking, determinism, and latencies in the communication. So K5, in the context of the CoreRide hardware continuum, is the kind of the missing pieces we had until now between the S32K1 and K3 general purpose controllers at the bottom, and the S32N and Z and G high performance real-time controllers, or processors I should say, at the top end. And so we are merging the properties of high performance compute and real-time and safety with low power and I/O control from the bottom, and to enable this zonal integration. Having software teams that are hundreds of engineers spread around the world work on a common target, whether it's a physical target like a board in a lab, or whether it is a virtual target like a design and simulation environment, that allow them to synchronize on the same thing all the time. And that is a huge productivity gain. And that's why NXP provides a virtual design kit that is available for our customers to use the product, not just before silicon is available, but actually after silicon availability, that can scale their development so much faster that it's another factor of efficiency that we are really, that's really part of the CoreRide platform to enable this S32 cloud-based environment.